Hi, my name is James Pachicara. My partner's name is Mauricio Ponce, and this is the video summary of our project. The PFAS dataset that we chose to use for this project consisted of a contaminant levels of various chemicals within water systems across the United States, along with sampling site details and a flag variable indicating whether the chemical exceeded the minimum reporting level. We decided to use only the observations from Texas to deal with the high number of observations. In addition to that, we use a zip to county dataset to assign counties to each of the observations. And we did that so that we could use predictor variables from the American Community Survey data, which provided socioeconomic and demographic information at the county level. Some data cleaning that we had to do was handle missing values and filter out any irrelevant observations. And we were left with a data set that had a total of 288,000 rows and 288,171 rows and 43 columns. And the variables you see here are some of the variables that we look at in the data exploration. Getting into that, we use various bar charts and box plots to understand variable spread and look for any flagged outliers. Additionally, we created a heat map to show the proportion of observations that were flagged in different time periods. We use these bar charts, and what we see is that the proportion of flags were higher in the earlier years compared to the later years. And we use these bar charts to help further look into this. And what we see is that the increased number of tests in the later years, shown in the bar chart on the right, might be the cause for the lower percentage of observations being flagged. Additionally, we created a correlation heat map to identify any strong relationships across variables, and what we found was that many of the ACS variables were highly correlated, especially the income, housing, and demographic metrics. This motivated us to apply dimensionality reduction techniques such as PCA and factor analysis. And the idea of this was to group those correlated variables into principal components that could represent broader latent factors. And so that is what we did, and we were able to come up with three principal components, which were shown below. And what we see here are how the different ACS variables load into these principal components, and the bolded ones show where we think each of these variables would load. So now that we were able to simplify these into three components rather than having all these variables, we plugged them into a logistic regression model along with a few other variables, and we got the coefficients you see here, and that allowed us to create the interpretations for the principal components that we output into this right here. Now getting into the predictive model, the goal of the predictive model was to be able to predict when a contaminant will be flagged, and our goal was to maximize the predictive accuracy over interpretability. And so to do this, we included county in our predictive model because by doing that, we were able to leverage the historical patterns of the contaminant flags. And so we ended up deciding to use AutoML from the H2O package, and this allowed us to automate the model selection and tuning process. We hyper-tuned it to use 10 machine learning models and including ensembles to identify the highest performing option. And after we got the best combination of models, we input that into a confusion matrix and we were able to get a test accuracy of 92%. And then, so the last thing that we wanted to do was we wanted to try and see if we were able to explain the level of contamination of the contaminants that do go above the MRL. And so to do this, we filtered out all the observations that were not flagged, and we created a sub data set that contained all the observations that were flagged. Then what we did was we created a new variable called analytical result percent change to help scale for the differences across the sites and contaminants, since each of the contaminants have different minimum reporting levels and different values. And then this time what we did was we applied factor analysis instead of PCA to the same ACS variables with the same goal of reducing the dimensionality. And so, similar to the PCA analysis, we were able to come up with three different groups in the factor analysis, and we show each of the variables load in each of these groups. Then this time we did a linear regression model, and we outputted the summary here. And similarly, using those coefficients, we were able to come up with interpretations for each of the groups from the factor analysis. So some of the conclusions that we were able to come up with from this project was that contamination risk concentrates in dense lower income and industrial areas. Additionally, we learned that wealthier, newer housing areas experience reduced contamination. And we also learned that in the process of trying to predict contamination, we found that prior contamination is a really strong component in predicting future contamination. And then here are some data limitations as well as some additional notes we have. But thank you.